The most volcanically active island in the entire archipelago is La Palma. La Palma hosted about more than half of all the eruptions in the historical record, and the big one was in 2021, and I'll have a separate lecture about the 2021 eruption when we are on La Palma. So La Palma has an old volcanic shield, the Taburiente shield in the north, and a new ridge that's growing and it's continuing underwater. It's called the Cumbre Vieja Ridge. And the Cumbre Vieja Ridge is pockmarked with volcanic cones, and this is where all the historical eruptions occurred. And we have quite a record of them. So here on the little map on the right, you see the historical eruptions. In the top left, there's a photo from the 1949 eruption. The top middle one is the 1971 eruption. And the top right is a night view of the 2021 eruption. The image in the bottom is a view towards the old shield volcano from the active part of the island, volcanically active part of the island. The old part is now extinct, so if you want to buy a property on La Palma, I recommend the northern part. So the eruption, as I said, was a big eruption, and it led to the displacement of more than 8,000 people and damages on the order of €1 billion. So that has been a bit of a disaster, but as I said, we'll talk more about this when we are on La Palma. So I'd like to spend a little bit of time now to explore how the volcanoes of the Canary Islands actually form. And I told you that the islands are all a little different. They're not quite the same. And this is because they're all of different age. So here, looking from the west towards the Canary Islands and draining all the water away, so you see Tenerife, you see La Gomera, and the small islands of El Hierro and La Palma. And there's a tiny little seamount, a submarine volcano that's growing now. It's called Las Hijas, and maybe this might become the next Canary Island when it's grown properly to full size. What we realize when we look at the Canary Islands is that there seems to be an age progression in terms of shape. The young islands with a lot of volcanic activity are in the western part of the archipelago, and then the big islands, the large ones, are in the central part, and the flat islands are in the eastern part. And that gives us an idea about the age. Obviously, the longer the island is around, the more erosion happens, meaning the flat islands are a lot older than the younger and steeper islands in the west. So the archipelago has 7 main islands. Some people will tell you it's got 8 islands because there's the island of La Graciosa, which is a bit of a debated thing. La Graciosa is a funny little island off Lanzarote, and not a lot of people live there, but it was actually the island that inspired writers to talk about treasure islands, because apparently there's a pirate treasure buried there. Nobody has found it. Loads of people have looked, but maybe you're lucky. So I leave that up to you. So 7 major islands and a small one, La Graciosa. And the islands, they are all volcanically active, but more so in the western part. And as I said, there is an age progression. And in this little map down there, let's see whether I can get this to work. Yes, here we have rock ages, radiometric rock ages, and Fuerteventura and Lanzarote, the oldest rocks we have is 20 million years. For Gran Canaria, 14 and a half, about 12 million for Tenerife, and then it gets younger. Gomera is 9 million, and here, these 2 youngsters here, 1.7 million and 1.1 million for El Hierro. So there's an age progression, and it's actually very similar to the Hawaiian Islands. And how does this come about? Well, I'll show you that one rival hypothesis is there's a fracture lying underneath, and the volcanoes might just come up the fracture. We're not entirely sure about that, because if you look at the Azores, and we have a little map up there, the Azores, they sit on fractures, they sit on plate boundaries. All the islands are really long, and there is no age progression, and there's loads of earthquakes. So if you look around, sorry, I'll come here. Here's the plate boundary. It's a triple plate boundary in the central Atlantic. That's where the Azores sit. Loads of earthquakes. So this is out here. But if you go further down, very few earthquakes in the Canaries. So, and some people say there's a connection to the Atlas Mountains here in Morocco, but there's no earthquakes in between connecting them. So I don't think the fractures really work. We have to think about something else. And this is a model that was postulated in the 70s. It still seems to be the best one, and that is the model of mantle plumes. That means we have hot fingers of material that rise up in the mantle, and we have a plate that moves above ever so slightly. And over the millions of years of Earth history, you actually get a chain. It's a bit like a Bunsen burner under the moving Earth crust, and that's also what we believe for Hawaii. If we want to believe that, then, well, how does the plate actually move? And can we see other archipelagos that do the same? And in the bottom right here, there's the Madeira volcanic trend of the volcanoes, even including the submarine ones and the Canary ones, and they both follow a similar trend. We can project it to a pole of rotation. We call this an Euler pole, and this is what happens there. The African plate is rotating around this, and it's moving into Europe ever so gently on a daily basis. So when we look at this, we have now the opportunity to also use seismic waves to look deep into the Earth. And is this true that there's fingers of material coming up? And if you look in the top right, the red colors of this tomography image give you anomalies and materials that are very hot. And there you see under the Canaries, we have this area of redness. It's a little wiggly, but it seems to imply that there's material rising up from very deep inside the Earth. And this leads to a little diagram like this, and this should actually work. It's a little video. Yes, it works. So the idea is that we have a moving plate, and the oldest islands form first, but then the plate moves and takes them away, and then they get eroded, they get shallower and shallower, and then new islands form along the way. And if they are not that old, they might be still tall like Tenerife, and then we have the very youngest islands forming, well, geologically very recently, and that's where the volcanoes are right now. That's where most of the volcanic activity is, because they sit pretty much directly above the heat source. So coming back to how the Earth works inside, in the bottom right, there is an image from the 1600s from Athanasius Kircher, and he had the idea that there was fires inside the Earth and they would come up. We know a little more today, but the Earth still looks like a big mystery to us. On the left-hand side, we have the current understanding. We have an inner and outer core, and they are the heat sources. And then we have the mantle, and there's various anomalies in the mantle. Some of them are mantle plumes that rise up, and here's the one. Sorry, it's very hard to operate this arrow. So here's the one that feeds Hawaii. And, well, down here we have several ones, and these are supposed to be the Canary Islands, the Cape Verdes, and the Madeira archipelago. So then I'm gonna spend a few more minutes on the geological features, and this is the key geological features. And for that, I'm gonna start with this image from Tenerife. This is in the national park, and there we have young lavas that are flowing over old rocks, and this was actually a lava fall, a cascade. So it's like a waterfall, only with lava, and it came over a cliff, this lava flow, and then it was falling down, making these spectacular features. So I'd like to talk about rift zones and giant landslides. I mentioned them earlier. Briefly touch on lava tunnels, and if we have time, I'm going to run you through the recent and historical eruptions of the Canary Islands. Tenerife has this strange shape with three main arms, and the main volcano sits right in the middle. We call these long arms rift zones. And all of the historical eruptions happen along the rift zones. The top right image gives you a flavor. There was eruption 1705, 1706, 1798, and 1909. The lava might flow all the way to the sea, but the eruption centers are usually on the crest of these ridges. And we have these rift zones, not just in the Canaries. We also have them on Hawaii. In the bottom right, you see vent alignments in Hawaii. Actually, the Canary rift zones are better defined than those on Hawaii. So many scientists come here, even from the US, to study how rift zones work. And the old little volcanoes that formed Tenerife, like the old shield volcanoes, Anaga and Teno, they had their own rift zones. So it seems that volcanoes, once they grow to a certain size, they start to have these internal fractures that allow to bring magma up, but very often they also host giant landslides. And this is what the Canaries are famous for. Here's a few impressions. The left one is looking down the rift zone towards the northeast from Teide volcano. And here, now we're looking back from the northeastern end, from the Anaga Peninsula down to Teide. You see the long ridge. It's a bit wiggly, of course, but these rift zones are the main volcanological features of the island. And this is the same, as I said, on La Palma. We have this rift zone, and it's called the Cumbre Vieja, the Old Ridge, as it's locally known. And there we have all the volcanism. So rift zones are the real dangerous part. And, oops, let's go to this one here. And you may have heard about this big threat that was publicized some 20 years ago, that if La Palma has another eruption, it might actually collapse into the sea. And it might produce a giant tsunami, a wave, and the wave could travel all across the Atlantic. And it could actually hit the eastern seaboard of the US. It would be still tens of meters high and it would come with enormous speed. And it all goes back to this particular feature, this crack here on the right. This crack opened up during the 1949 eruption, and geologists started to speculate it could actually have a part of the island collapse away from the main part. Luckily, nothing happened during the 1971 eruption, and again, nothing happened during the 2021 eruption. So we also have instruments there to, well, measure if the flank of the islands is actually moving, and it's not. So we're safe for now, but the reality is these landslides are real. They are giant landslides, and giant means 100 cubic kilometers of material. Let me give you a flavor of this. The eruption of Mount St. Helens in 1980 produced a lava volume of 0.8 cubic kilometers. So this gives you a flavor of the dimension of these landslides. And as I said, this was in the press. This was very big in all sorts of languages when a team of scientists published this around about 2000. And here's the models. So this is the modeling of the tsunami wave if there's a big collapse of La Palma in the top left. And then we have a time stamp here in the top right, 5 minutes, 10 minutes. And then ultimately in the bottom right, after 9 hours, the wave would actually hit Florida. So this is something that's geologically quite realistic, but the probability of such an event is extremely tiny. So that we would see that in our lifetime is highly improbable. So I was there with National Geographic a few years ago, and I told them, this is very, very unlikely. And I said it at least 25 times. But of course, in the final program, it was the worst case scenario is. And yeah, so when you see this documentary, even if I'm talking in there, it's actually very, very unlikely. But it can happen. So then, having seen that, we have many of those landslides on the other islands as well. And I'm gonna run you through a few of them. We have the island of El Hierro, which has these, well, bites. And these are actually landslides. These are large chunks of the islands that fall off. And here's a geological map of El Hierro. Green is again the younger volcanics, and there you see that the youngest volcanics are in these landslide scars in these embayments. So, and this is the El Golfo Valley. It's the youngest of all the landslide scars in the Canary Islands, and it's only about 140,000 years old. So here's an older one, the El Julan landslide, and here is yet another one, the San Andres landslide on El Hierro. And these are beautiful for research, but I would not be actually scared in any way right now. there would be a lot of signs before these landslides reactivate. There would be a lot of earthquakes, and we don't see anything like this right now. So this is the fault line of one of these slides, and there you can really see a steep fault where one mass of rock on the right-hand side was sliding down, and the one on the left was stable. And this is me trying to scale the fracture surface in order to get a sample of glass. Oops. In order to get a sample of glass for age dating. We did get the sample of glass, but the age date didn't turn out very well. So let's look now at Tenerife. Oops. Let's look now in Tenerife. The Las Cañadas caldera in which Teide sits is supposedly also a giant landslide. And there's some debate about this, but recently marine scientists found a giant avalanche of deposits. So the big caldera there may actually had at least part of it collapsing into the sea some 200,000 years ago. If you go to Gran Canaria in the top northwestern cut, there's a bit of a bite in the apple, and on the left-hand image you can see that curved feature, the curved coastline, and that is a Miocene landslide about 10 million years old. And when we go to some of the older islands, then we can still see signs of landslides in these very curved coastlines, which are bays effectively, and that's what we see here even on Fuerteventura, although it's not as obvious anymore. Well, my watch says I have about 7 minutes left, so I'll treat you to some volcanic caves as well. So the Canaries have some of the longest volcano tubes or lava tubes in the world. And if you're really interested, you will have the opportunity to see some in Lanzarote as well as on Tenerife. The image in the top right here is, well, lava sickles, as we call. This is drop stones that actually come from lava. So if there's lava flowing through this tube, then of course the roof gets hot and it can remelt some of the older lava, and then you get these lava drop stones. Geologists love them. And so there is some of these caves that are well over 20 kilometers long, and well, there's some tourist caves, I guess, where you can visit with a guide. But it's almost a sport here on the island for people caving, and every now and then people also get lost and don't come back, unfortunately. But that's what it is. So how do they form? Well, if you have lava flowing, it starts to cool on the surface. It's still hot on the interior. It starts to actually harden at the rims, and you start to make a little, well, a little channel for it, and eventually it's going to overcrust. And it's still going to be runny inside, although it's overcrusted. The images on the right here are from Hawaii, where you see lava flowing underneath, but there's already a crust. And this very brave geologist here on the top right is standing right above flowing lava there. And, well, the lava crust may be that thick or so, but, well, it seems to hold. And here's just an illustration of how this works. We have lava flowing, and the interior then will continue to flow, although the outside solidifies. Every now and then it breaks through as well, through a little skylight, and there you get little tiny cones. We call them hornitos, little ovens. It's a Mexican term, and these are actually very good because they mark lava tunnels that are underground. So when you want to build a house and you see hornitos, it's not a good place to buy. So, and yes, just a few closing words about the lava tunnels. Well, we get a lot of fossils in there because in the old days, 1 million years ago, for example, some animal accidentally ended up in there, died, and there we know that the islands here had a giant canary rat. It was about this size, can you believe it? And it's extinct now, thank God, but it lived in these caves to a certain degree. And some of the local spiders are also going, and they live in these caves. And there, for example, you see the one that's in broad daylight in the bottom there. It's very colorful, and its relative who went into the cave well, it decided that it's a good idea to be rather invisible in the cave and be black. So it actually turned black. And I remember one of my early cave visits, I was there with this guide, and the guide said, so now we're going to switch off the lights. It's going to be completely, absolutely dark. And I go, yeah, go ahead. And then he switched off the lights. It took about 30 seconds, and somebody was this loud squeak by one of the other people in there. And that lady went with her hands against the wall. And there was loads of black spiders. And of course, the light was switched on again, but yeah, there was a bit of a panic situation for a few moments. So if you ever go into these, be careful with the spiders. They're not super dangerous, but they're not very pleasant, I find. So, closing words. Cesar Manrique, one of the local artists in Lanzarote, he's really famed for working with landscape, and he used some of these lava tunnels to make artworks out of it. So he was big into integration of architecture and landscape, and he made these rather interesting sculptures, like the one in the bottom right, where he built a house and he rearranged the lava in a way that the lava seemed to flow into the house. It's got a bit of a dark side, because actually during the 2021 eruption on La Palma, this was a very common feature. And suddenly, people were not quite so keen on this piece of art anymore. So, but he built various fancy kind of places, including restaurants in various lava tubes, and he also built a ball area, so you can go dancing there inside a lava tube, and there's even a concert hall inside the lava tube. So, with my remaining 2 minutes, I just gonna show you this slide here, and this is about the active historical volcanic eruptions on the island. The image on the right-hand side is a few of my colleagues and myself in front of the 2021 eruption. The image in the top left was the 1971 eruption, and the night image is from 2021. In the little diagram underneath, we have historical eruptions on Tenerife, on La Palma, and on Lanzarote. We have recent eruptions, recent meaning geologically recent in the few thousand years before present, but not recorded or witnessed. We have them on Gran Canaria and El Hierro, and Fuerteventura and La Gomera actually have the lowest historical volcanic record. So during the 21 eruption, a lot of people ask me, Val, where do we need to go to be safe from volcanoes? And that's the answer. You can go to Fuerteventura and La Gomera. But none of the islands is truly safe from volcanoes, because they're all volcanic in origin. Thank you for your attention.